Okay, everyone, so now that we've talked about finding the area of different quadrilaterals, we talked about finding the area of parallelograms, which was a simple formula, base times height, and that included rectangles and squares and all that. And then we also talked about finding the area of trapezoids, which is a little bit of a different quadrilateral that only has one pair of parallel sides. That has a little bit of a more complicated formula where you have to add the bases and multiply by the height and then divide by 2. So again, luckily you don't have to memorize any of these formulas. You can just pay attention to what figure it is and then use the appropriate formula. Look up the formula and use the appropriate formula. So today we're going to talk about finding the area of triangles. Now, I'm not crazy. I know this isn't a triangle that I drew on the board here, but I drew this figure for a reason. This was supposed to be a parallelogram. You know, as with all these drawings, my rendition might be a little off, but use your imagination that this is a parallelogram with the base here and the height there. And we know that finding the area of this, all you do is you do base times height. Right? That's it. Well, inside a parallelogram, how many triangles are there? If you think about it, if I draw this diagonal, could fit 2 triangles that have the same base, because those sides are the same, and the same height. So if I only want the area of one of those triangles, then if I multiply the base and the height, the area of that triangle would be half of the parallelogram that I just drew, right? So to find the area of the triangle here, I would do base times height, and then I would just divide it by 2. So the formula to find the area of a triangle is base times height divided by 2. But you have to remember to divide it by 2, because if you don't divide it by 2, you'll be finding the area not of the triangle, but of the parallelogram with that base and height. And if you don't want that, if you want the area of just the triangle, that's why we have to divide base times height by 2 to get the area of just the triangle. Okay? So let's say this triangle had a base of 8 inches and a height that was 3 inches. All right? You multiply the base and the height, 8 times 3, but then you have to divide that by 2. So that's going to be 24 divided by 2, so that's going to be 12 square inches. 12 square inches. Okay? So when you're finding the area of the triangle, you need the base, you need the height, you multiply them together, but then there's just one more step than there was from parallelograms, that we have to divide that amount by 2. Because a triangle would be half the area of a parallelogram with the same base and height. Okay? So that's all there is to it. So if I had a triangle, let's say maybe a flatter triangle like this with a long base, maybe this was 18 inches, and then maybe this right here was 1.5 inches. Right? So now all I would have to do again was multiply the base times the height, but then I have to divide it by 2. So I'm going to do, my area is my base, which is 18, times my height, which is 1.5, and then I'm going to divide that by 2. So 18 times 1.5 is 27, and then you divide that by 2. So make sure you divide that by 2. And it's 13.5. And we label it with square inches. So it is possible, obviously, to get decimal answers and things like that. Okay? So base times height, but then for a triangle, we're dividing it by 2. Okay? That's it. All right? So it's a simpler formula than trapezoids, but just has one little extra step than a parallelogram or parallelograms. Okay? Sometimes, again, the orientation or the way the triangle is rotated might be a little different. You might have a triangle that's an obtuse triangle that's like this. Okay? And so if we call this the base right here, maybe this is 10 inches, then sometimes we might measure the height outside of the triangle, as if you were like dropping something from the top here straight down to the ground, the height. So sometimes you might see them label the height outside the triangle. That's fine. If this is the base, then this is the height, right? Let's say that's 9 inches. So if you wanted the area of the triangle, this is the base. There's how high it is. So area would equal base times height divided by 2. 90 divided by 2, 45 square inches. So the triangle might be orientated different ways. It doesn't matter. Find the base, find the height that goes with that base, and then multiply them and divide by 2. Okay? A right triangle is an interesting case because in a right triangle, if you know the legs, for example, let's say this is 3 inches and this is 4 inches. If this is the base, we call this the base, then this leg is the height because it's straight up and down because of the right angle. So the area would be the base, which is 3, times the height, which is 4, divided by 2. So the area of that triangle would just be 6 square inches. Okay? So area of a triangle, pretty straightforward. You need to find the base, you need to find the height, and multiply them together. Those will be given to you, so just locate the base, locate the height, and then you have to divide it by 2. You have to divide it by 2 because a triangle is half of the area of a parallelogram with the same base and height. So that's why we divide it by 2. So for all these problems you'll be doing in the next couple of days, if they're triangles and you're finding the area, you're going to do the base times the height and then divide it by 2. And make sure you label your answer. With all area problems, the answer is labeled in square units. Okay? All right, folks, have a great day.